Hi everyone. Welcome to this tutorial. Today, we are diving into geographically weighted logistic regression, or GWLR. This powerful technique helps us understand relationships that change across space. Unlike traditional logistic regression, GWLR lets regression coefficients vary geographically. This means the effect of a variable might be strong in one area but weak in another. We will run a GWLR in R. It's a fantastic tool for spatial analysis. First, let's set up our environment. We need to load some essential libraries. These include SF for spatial data handling and GModel for the GWLR itself. If you don't have them, install them using install.packages, SF, and install.packages, GModel. Next, we need some data. For this example, let's create some simulated spatial point data. Imagine we have points representing locations where we want to predict a binary outcome, like the presence or absence of a species. We'll generate random coordinates, a binary dependent variable, 0 or 1, and a couple of independent variables. We'll convert this data into an SF object, which is our modern way to handle spatial data. This step is crucial for any spatial analysis. Ensure your data has a valid coordinate reference system, CRS. Now, let's define our regression formula. It will look like dependent underscore variable independent underscore variable underscore 1 plus independent underscore variable underscore 2. This is similar to a standard logistic regression formula. The next critical step is to determine the optimal bandwidth. The bandwidth controls the size of the local neighborhood used for each regression. A smaller bandwidth means a more localized model, while a larger one considers more data points. The bw.gwr function from the GModel package helps us find this optimal value. For logistic regression, we use bw.gwr formula data equals your underscore SF underscore object, family equals binomial. This calculation can take some time, especially with large datasets, so be patient. The optimal bandwidth minimizes a criterion like AICC. Once we have the optimal bandwidth, we can run the geographically weighted logistic regression. We use the GWR.basic function from GModel. The syntax is GWR.basic, formula, data equals your underscore SF underscore object, BW equals optimal underscore bandwidth, family equals binomial, kernel equals Gaussian. We specify the formula, our SF data object, the calculated bandwidth, the family equals binomial for logistic regression, and usually a Gaussian kernel for weighting. The kernel determines how weights decrease with distance. After running the model, the output will contain local coefficients for each independent variable at every data point. It also provides local t-values and p-values. These tell us how the relationship between our dependent and independent variables changes spatially. Interpreting the results is key. We can extract the local coefficients from the model output. The GWR.basic function returns an SF object with the results appended. We can then map these coefficients. Visualizing the spatial variation of coefficients on a map is incredibly insightful. For instance, you might see that independent underscore variable underscore 1 has a strong positive effect in the north but a weak or even negative effect in the south. This reveals non-stationary relationships that a global model would miss. You can use mapping libraries like tmap or ggplot2 to visualize these spatial patterns effectively. Remember to save your results if needed, perhaps using st_right to export the SF object. This entire process allows for a much richer understanding of spatial processes. And that's how you run a geographically weighted logistic regression in R. You've learned about setting up your data, finding the optimal bandwidth, running the model, and interpreting its geographically varying coefficients. This method is incredibly valuable for exploring complex spatial relationships. Thank you so much for watching this tutorial. I hope it was helpful. If you found this video useful, please give it a thumbs up, share it with your friends, and don't forget to subscribe to the channel for more content like this. Your support helps us create more valuable tutorials. See you next time.